Hey, party people. People who love to party. It's me, Mr. Bill, here to talk to you today about adding and subtracting polynomials. Step this way. Now, first, we probably need to go over what even a polynomial is in the first place. And polynomials got two parts to it: poly, which means many, and nomials, which is numbers. So it's a bunch of numbers. But I mean, more technically, it's an expression with whole numbers and variables with whole number exponents. Which means all this stuff right here, polynomials, look, whole number exponent, whole number. Mr. Bill, there's no variable there. There doesn't have to be a variable there. That's still considered a polynomial. Mr. Bill, that's not many numbers, that's one number. One is a type of many. We've got 9x plus 2, bam, polynomial. This is a polynomial. These guys aren't. Why not? Well, let's take a look right here. Bam, look at that exponent. That's not a whole number. Mr. Beal, 3 is a whole number. Yeah, I know that, but -3 is an integer. That is not a whole number. It's not the same category. Over here, we have a fraction. Ooh, fractions are whole numbers. Another one that wouldn't work is if I had 1/5 x to the 4th plus 2x. That could not be a polynomial. Mr. Bill, why not? That's not a whole number. Ta-da, right there. Now, these things have lots of different pieces to them, lots of different pieces. And probably the most important piece is the idea of terms. So as I look at this polynomial right here, it's got 1, 2, 3, 4 terms. And if you're looking at that, our terms are all broken up by addition and subtraction signs. So terms, I put them in those boxes. There we go. That's what gives you more than one term. So this bad boy up here, that's got one term. That's one term. But this, 1, 2 terms. This guy right here, 1, 2, 3 terms. It's the amount of terms it has. Now, beyond that, we also have this idea of coefficients. And you might have heard a teacher use this word before, and probably you ejected it from your brain because it could not process it. I'll put a little arrow on all of our coefficients. 4 is a coefficient. -12 is a coefficient. -5 is a coefficient. 19 is technically like a constant term. I guess you could call it a coefficient if you want to. It doesn't make much sense because the coefficient is a number in front of your variable, or the whole number piece telling you how many of those variables there are, so to speak. And after that, we have the idea of degree. Now, the degree of a polynomial, which I will circle, is the highest exponent on a variable in that polynomial. So this polynomial has a degree of 3, third degree polynomial. Whereas up here, well, actually, this is also 3, but this one, this would be there's a little 1 right there. That's a first degree polynomial. This is a second degree polynomial. The last part of this is we can kind of mix up this degree and coefficient to come up with a concept of a lead coefficient. And your lead coefficient, which I will give a little squiggly circle to, is the coefficient on the thing in your polynomial that is determining its degree. In other words, the variable with the largest power. So our lead coefficient here is 4. There's your lead coefficient. Nice. Sorry, that's so slanty. All right. So polynomials can be broken up into different categories, like monomials, which means just one number. That would be the 5x squared. And the 7 that you saw earlier, those are all monomials. This would also be a monomial: 12x to the 5th, y to the 9th, z to the 12th. Mr. Bill, there's no way that could be a monomial. It has too many variables. Yes, it can be a monomial. It doesn't have any pluses or minuses in it. It's all just one big, ugly, fat term. A binomial is 2 terms. So like 9x plus 2. That's a binomial. We'll be working a lot with those. Trinomials we will also work a lot with. And that could look like the 4x cubed minus 6y z to the third plus 1, which was up there at the top as well. It has 3 terms. 1, 2, 3. Trinomial. Everything after that is a polynomial. So if I were to use 5x squared minus 3y plus 2x plus 7, you may be thinking to yourself, great, quadrinomial. No, polynomial. We stop counting after 3, which seems strange in mathematics that all we have the capacity for is 3. More importantly, polynomial names all the other things. So 5x squared is a polynomial. 7 is a polynomial. 9x plus 2 is a polynomial. 4x cubed minus 6yz to the third plus 1 is also a polynomial. All of these are polynomials, many numbers, even the 1. Okay, so let's get down into some math though. What can we do with these bad boys? And as a matter of fact, we can do quite a bit. But we're going to start off with the easiest stuff, which is adding and subtracting. Now there's a couple different methods for adding and subtracting polynomials. One of them that I am not that great with, it's not really my favorite, is you take the stuff that's over here and you match it up with these guys. So you put a plus sign and you match like terms, which is to say same variable and exponent on the variable goes with same variable and exponent on the variable. So I'm not worried about the 7 or the 2 per se, but the fact that this is x to the first means that they would line up. And the fact that this doesn't have any variable on it at all means that these guys would line up. And then I would just add down. So negative 4 plus 8 is 4. 7 plus 2x, 7x plus 2x is 9x. Ta-da! There's our answer, 9x plus 4. Now the way that I learned to do this was actually by drawing different shapes on the different types of variables to keep track of them, rather than moving one thing over another. So for the x, I might do a circle. There's all my x's, found them. And for all my 1s, or the things without a variable on them, I might do an underline. And I just add the circle stuff to the circle stuff and the underline stuff to the underline stuff. Once again, giving me 9x plus 4. 2 different ways to do the same thing. Here, I'll show you again on this next one. So for this part, if I were to write the thing under it for this guy, I would need to rewrite it because, as you can see here, I go from y to the third, y squared, and then I skip a y, but I have a y over here. So I have to make that space. So this would be 5y to the third plus 4y squared blank minus 10. And then I'm going to put this stuff under it with a plus sign because I'm adding. Y squared plus 6y plus 3. And then I'm just going to add straight down along these categories. So I end up with 5y cubed, because there's nothing there to add, plus 5y squared plus 6y minus 7. Nice, doing good so far. Now, that's one way to do it, and the other way is with those shapes like I was telling you about. And so in this case, I've got a bunch of stuff. I like to, in the squared ones, I like to make them into boxes. Notice how I'm taking the sign in front, because I need to know whether it's positive or negative or not. I like circles for my single variables. I like lines for my 1s. And this guy, man, there's only one of those. I'll make it a star. Why not? So I'm going to add my boxes to my boxes. 4y squared plus y squared is 5y squared. There's no other 6y, so I just say plus 6y. There's no other y to the thirds, plus 5y to the third. And then negative 10 plus 3 makes negative 7. It's the same way as I did all of the rest of them. So for this last one, I'm definitely going to pick one way or another. Actually, no, maybe I'll just show it to you. Why not? One more time before I start picking ways instead of doing them every sort of which way. All right, I'm going to put stuff under what it goes with. And you'll notice that we've got crazy variable expressions now. It's like, whoa, but I'm looking for same power, same stuff. So if I give this one let's give this one a triangle. Do I have any other p to the fourth r to the thirds? Nope, nope, no. So he's going to be on his own. 8 p to the fourth r to the third. Over here, let's make this a box. Do I have any p to the thirds r squared? Ooh, there's a p to the third r squared. I give that a box too. None of the rest are that. Let's see, I've got 5r cubed. There's another r cubed. And the leftover one looks like 2r squared. So matching stuff up, my boxes, -4 and 14 is going to be plus 10. And I'm just writing down the p to the third r squared because that's the type of term they were. 5r to the third minus 3r to the third is plus 2r to the third, and then plus 2r squared. You can tell that I like doing this way better than other ways, for sure. Otherwise, what you got to do is you would be matching up these pieces under this guy. You'd put plus 14 p to the third r squared. You'd move your minus 3r cubed up under here. And then there's nothing there, so I could just put this like in space kind of floating out here with the r squared, and we will get the same thing lining up right there. Our answer is this stuff right here. And that's as far as we can simplify it because it's plus, not times. We can't join them together anymore. All right, subtraction. Works a lot the same as addition. The only deal is everything after the subtraction sign, you got to change its sign because you're minusing all of that stuff. Now here it makes a lot of sense. I could even move this under here with the minus sign, minus 9m squared, and I've got a 4. And you'll see why I like to change the sign. I need to minus 9m squared from this. I've got 8m squared. I need to minus 4m from 2m. I've got negative 2m. The thing that I always worry about is, what if I forget to get this minus over to here too? So before I do anything, especially since I like to draw those shapes, I turn this into a plus sign, bam. And since I've changed that sign, I change the sign of everything after it. And then I go and make my shapes. Box, box, circle, circle. Now I've got 17m squared minus 9, 8m squared. I've got 2m minus 4m, negative 2m. Same thing, two different ways to think about it. So I'm definitely going to do my way right here, for sure, which is boxes and stuff. So get used to it. I'm going to change the sign, bam, minus, plus, plus. Now I go back through. Do I have any other x squareds? Oh, there's one. So that would be negative 3x squared. How about x's? Oh, there's another x. And that changed to a plus, so now it's going to be plus 12x. Oh, do I have any ones? Yes, looks like I'm going to end up with negative 5. Same as adding, all you do, you change that sign and every other sign behind it. I used to have a kid who used to call that unnegatizing stuff. That's not a word. That is not at all appropriate or correct. Alrighty, for this next one, I'm going to do the same thing that I did before. Rather than moving them under here, which would cause me to rewrite it in this particular instance, I'm going to change the sign. Bam, change the sign, change the sign, change the sign, change the sign. Notice how I'm scribbling out those plus signs because I don't want to get confused. Do I have any d squareds? Yes, I do. Do I have any d? Actually, let's do that part first. So it looks like I've got 12d squared because I've got 5d squared plus 7d squared. After that, I've got negative 13d and a negative d. That's negative 14d. And I've got a 6 and a negative 2 makes plus 4. Did I forget anything? Bleep, yes, I forgot something. Forgot that d to the third. You can see everything has some sort of shape or something on it except for that. We'll give it that triangle again. And that'll have to go up in the front because it's the highest degree. Notice how we keep ordering these things over and over again in descending order. Third, second, first, none. Second, first, none. This is the proper way to write these things. Okay, guys, I'm going to give you 2 to try, and only 2. You're going to do work after that, but I figured this is a pretty basic concept. Do those. I will pause it. Answers when I come back. I'm back. Time for answers. Yeah, there we go. 8x squared minus 8x minus 6. And in this case, 5a squared b to the fourth minus 2a squared b to the third plus 4. Oh, yeah. All right, guys. So endeth the trick. Stay safe out there. World crazy.